scientists have discovered never-before-seen patterns beneath a floating ice shelf in Antarctica following an expedition to create the most detailed picture ever of the glacier's underside. The strange teardrop shapes were discovered below Doston ice shelf in West Antarctica in 2022, when a remotely operated vehicle ROV dove 10 miles (17 kilometers) underneath the glacier and traveled more than 600 miles (1,000 kilometers) along the underside of the ice. The researchers published the findings of the first-of-its-kind survey Wednesday, July 31, in the journal Science Advances. In order to understand the ice cycle in Antarctica and how ice gets from the continent into the ocean, we need to understand how it melts from beneath, a process that is equally important as calving for moving land ice to the ocean, study lead author Anna Wallen, a professor of oceanography at the University of Gothenburg, told Live Science. Doston ice shelf is a 30-mile wide, 50 kilometers, chunk of floating ice 7 times the size of New York City, located on the coast of Marie Byrd Land in West Antarctica. It is part of the West Antarctic ice sheet, which has dramatically calving glaciers that could cause sea levels to rise by approximately 11 feet (3.4 meters) if they eventually drive the entire sheet to collapse. Steady erosion is nibbling away at the fringes of the ice shelf, with warm ocean water infiltrating its undersides and unpinning it from the land, making its eventual collapse inevitable, previous studies showed. To further investigate the processes threatening the 1,150-foot thick, 350 meters, ice shelf, the researchers sent the ROV below the ice to scan the glacier's underside with sonar, building up the most extensive and complete picture of the glacier's underside ever. Much as the scientists expected, the survey showed that the glacier is melting fastest at the points where underwater currents are eroding its base, and fractures running through the glacier are helping the melt to travel up to the surface. But unexpectedly, they also discovered that instead of being smooth, the glacier's base is flecked with teardrop shapes emerging from peaks and valleys in the ice. Some of these shapes are up to 1,300 feet (400 meters) long. The researchers believe these weird patterns are created by uneven melting as water moves with Earth's spin across the glacier's underside. The result is a spiral flow pattern called an Ekman spiral, which is most commonly seen when winds travel over surface water, but can also be created by water traveling over ice. To follow up on the survey, the researchers returned with the ROV in January 2024, but the submersible got lost and disappeared beneath the ice shelf. The team's next goal is to return with a new sub and continue surveying the uncharted depths beneath. It takes a lot of energy to melt ice, so all the ice in Antarctica is like a giant temperature stabilizer and an important part of Earth's climate system, Wallen said. If the Antarctic ice sheet were to end up in the ocean at high rates, it can potentially influence sea level rise, so if we learn the upper and lower limits, we can also put limits on future sea level rise.